Hey, welcome back. We're going to talk about trigonometry again. Today we're talking about how to find an angle measure using our trigonometric ratios of sine, cosine, and tangent. What you need to do is figure out first, which trig ratio do you have? Do you have sine, opposite over hypotenuse? Do you have cosine, adjacent over hypotenuse? Or do you have tangent, opposite over adjacent? And how do I figure out which one I have? Well, first, check out where your angle is, your angle of reference. We don't know what these angles are, so they're just question marks right now. To find your opposite, draw an arrow straight down the middle of your angle to the opposite side. There's your opposite. Your hypotenuse, we know, is always across from the right angle, and then that leaves your third side to be the adjacent. From there, what you need to do is identify which trigonometric ratio are you using. Well, what do you have? I have opposite side of 19, and I have the hypotenuse of 27. So I'm going to look for which one of these three down here uses opposite and hypotenuse. And it looks like sine is our big winner. So sine of what? It's always sine of an angle. But I don't know what this angle is. It's just a question mark. So what do I do in algebra when I don't know a value? I can just put an x in there. So sine of x equals, okay, now sine is opposite over hypotenuse. What's our opposite side? It's 19. What is our hypotenuse? That is 27. And this is just like what we would have done before. The only difference is that my x is now in the sine or in the cosine or in the tangent function. So just like when we got rid of our dividing by multiplying, we need an opposite operation. We need something to undo sine or undo cosine or undo tangent. And if you look on your calculator, sorry about that, if you look on your calculator, you might have something that looks like this. That's sine inverse. That is the opposite operation of sine. This undoes the sine function. So what I'll do is I'm going to undo the sine function on each side. So these would cancel out. I'm left with just x. And then I've got to do the sine inverse of the other side, 19 over 27. And that's really the key. This is the thing that's going to tell me my final answer. So I can type into my calculator sine inverse of 19 over 27. You might have to hit a second button and then the sine button on your calculator. So if I type in sine inverse of 19 over 27, then I will get, and it should be in degree mode, I will get 44.72 degrees. I'll just round that to 44.7 degrees. Let's try 11. Okay, first of all, again, identify what parts you have. There's my opposite side. My hypotenuse is always the biggest side across from the right angle. That's the adjacent. So it looks like I have the adjacent and the opposite. Well, what uses adjacent and opposite? That's tangent. So the tangent of what's my angle? Oh, I don't know that, but I know that anytime there's an unknown, I can put an x there. So the tangent of my unknown equals the opposite, which is 34, over the adjacent, which is 42. And again, what we end up doing is our inverse. Anytime you want to find an angle, just use your inverse. So this would be tangent inverse of, and the tangent and tangent inverse cancel out, and I end up with just x on that side. And then on the other side, I would do the tangent inverse of 34 over 42. So x would be equal to the tangent inverse of 34 over 42. And if I type in that into my calculator, tangent inverse of 34 over 42, let me get rid of that highlighting, then I should get from my final answer 38.99, or I could just round that to 39 degrees. Take a couple minutes, see if you can get 10 and 12. And then pause the video while you're doing that, unpause the video when you're done, and check your work. Alright, so here's my opposite side. Just draw that arrow straight down the middle of your given angle. In this case, we don't know it. Just straight down the middle of the question mark. Identify what parts you have. That's your opposite side. Your hypotenuse is always the biggest side across on the right angle, and then your adjacent is the third side. So it looks like here I've got hypotenuse and adjacent, and in 12 I have, well, all three, so we'll talk about that in a couple minutes. That's a fun problem. So I have adjacent and hypotenuse in 10, which means I'm going to use cosine. So cosine of my unknown angle x equals adjacent over hypotenuse. I'm sorry, this should go up here. Adjacent over hypotenuse. Well, what's the adjacent? 52. What is the hypotenuse? 56. And again, since I don't know what that angle is, I need to undo this to get the x by itself. So I'm going to cosine inverse on both sides. These cancel out. I'm left with just x. So I would be left with just x on that side. But then I've got to do the cosine inverse of the other side. 52 over 56. So my final answer there would be whatever this turns out to be in my calculator, the cosine inverse of 52 over 56. And if I type that into my calculator, maybe it's a second cosine, 52 over 56 would be 21.79 or 21.8 degrees. All right, now number 12. This one's kind of a fun one. You could have used any one of these because you have opposite and hypotenuse, so you could use sine. You have adjacent hypotenuse, you could use cosine. You have opposite and adjacent, so you could have used tangent. So pick your favorite one. My personal favorite is sine, so I'm going to use opposite and hypotenuse. But you could have used any one of these three. So sine of my unknown angle x equals opposite over hypotenuse. Okay? So the sine of my unknown angle equals the opposite over the hypotenuse. Well, how do I undo sine? I'm going to do the sine inverse to both sides. So the sine and the sine inverse are opposite operations. They cancel each other out. So I'm left with just x on that one side. So I would have x equals the sine inverse of 76 over 95, and if I type that into my calculator, then what will I get for degrees? 53.13 degrees. Or 53.1 degrees if you want to round to the tenths. So check out the video on how to find a side length if you haven't seen that one yet, and send me whatever questions you have in an email or ask me tomorrow before or during class, and I would be happy to help you out. All right, thanks guys. I'll see you later.